Okay, so here's our semester review. We're starting out with some administrators collect data on students attending the school. Which of the following variable is quantitative? We talked about this, that excuse me, that we could either consider grade point or none of these. If they're classifying them, kind of like they were saying, they made all ones or all twos or all threes or all fours or all zeros because of that's what a grade point average is, that would be categorical. But if we're saying it's a grade point average such that it's this kid has a 3.2, this kid has a 2.1, weighted scale, non-weighted scale, whatever, we can say that that's quantitative, but that's a kind of a wishy-washy question, so we won't need to worry about it. Okay, the next one, which of the following variables would most likely follow a normal model? Okay, scores on an easy test would be skewed to the left. In other words, if we had a line here, those tests would be like this, where most people were scoring 80s, 90s, and 100s, and very few people would be scoring 40s and 50s. That's skewed to the left. Singers in a co-ed choir would probably be something where a bunch of in the 50s and 60s, a bunch of females, no offense, ladies, down in this area, and then a bunch of males around the 6 feet area. Okay, 60 inches to, well, 5 foot and up. But anyhow, you see what I'm saying. More females lower down. This is 5'0", this is 6'0". Okay, so weights of adult male elephants. Now, weights of, because we're talking about a ton of things, no pun intended there, a ton of elephants, a lot of elephants, then that more than likely would be part of a normal model. Family income would probably look like this, that there'd be a lot down on this end, and then there's a lot of people like some of you making a whole lot of money would be skewed to the right. So that's going to be adult males. Okay, number three, the model, excuse me, is symmetrical. Okay, so it is approximately symmetric. The mean and median are approximately equal. They're both somewhere in this range, and this is only between, it looks like -2 and 2, but somewhere in this area, definitely the median's here, and the mean is probably really close to that. Now it says the mean IQR summarize the data better. No, we want to use, for things that are skewed, we use median and IQR. If it's roughly symmetric, we want to use mean and standard deviation. So this is 1 and 2 only, so that answer is D. Whoever had this, mark C. Then it says, which of the following data summarizes, um, which of the following data summaries are changed by adding a constant to each data value? Okay, if I add to every value on a list, if I add 5, then the mean will increase by 5. If in every one I add by 5, then the median will increase by 5. If I add to every number of 5, then this will not. Standard deviation is the shape of it. It's our distribution. It's how far they're spread apart. It's not changing. That answer is B, 1 and 2. Okay, number 5, the Society to Prevent Cruelty to Animals. Sorry, let me adjust there. Uh, Following data on the dogs they house, which of those is categorical? Which is categorical is breed. That is breed. I think someone marked the wrong answers just so someone would see this. Breed is categorical. The others, vet cost, weight, age, and number of days housed, that would be quantitative. This one, what's true of the data in the histogram? Okay, this is skewed. There's my tail. It's skewed to the left. This says it's skewed to the right. No, it's not skewed to the right. It says the mean is probably smaller than the median. This is true. With it being skewed this way, these lower numbers pull the mean away from the median. Here's my median. It's pulling it this direction. So that's a true statement. And since it's skewed, the median and IQR we use to summarize. So this is 2 and 3 only. Number 7, we might choose to display data with a stem plot. Okay, a stem plot looks like this. Okay, that's a stem plot. Okay, remember a box plot looks like that. Whoops. Sorry, you're not on there. Correct. There we go. Sorry, just the screen. This shows the shape of the distribution. This does not. We don't know what the shape of this is. So the stem plot does. Is better for large data sets, not the stem plot. Box plot does that better. Displays the actual data. This does not. So this is 1 and 3 only. So this is B, 1 and 3 only. Okay, 8, 9, 10, 11, 12, and 13 are all about linear regressions, and we don't cover linear regressions, so we're not going to worry about those. Okay, company with a new search engine wants to collect data on the ease of using it. Best way to collect the data, there's a lot of people that use it. It's a sample survey. The best way is a sample survey. Large populations, we want a sample survey. Okay, chemistry professor teaches a large lecture class, surveys the students who attend class about how he can make things more interesting, hoping to get more students to attend. Well, that's who he needs to ask, those students who are not attending. So that suffers from definite undercoverage. He's not asking those students. Those are the ones he needs to ask. Okay, placebos are a tool for control. Placebos are a tool for control because they allow us to control, to give us a comparison of other data sets. Okay, number 17. Which of the following is not required in experimental design? Well, you need control, randomization, and replication, but you don't need blocking. You do not need blocking. So that would be my answer. Okay, number 18. We wish to compare the average ages of math and science teachers here at the school. Well, there's only 14 of us, so the best way to collect that data would be to do a census. Sample survey of 14 people doesn't make sense. Run an experiment observational study definitely doesn't. A simulation of what? So that's a census. We need to do a sampling method, so it's either going to be A or C, and A makes the most sense. And then the last question, suppose the state randomly tests high school wrestlers for steroids use. There are 16 teams in the league, and each has 20 wrestlers. They plan to test 32 of these athletes by choosing 2 from each team. Is this a simple random? No. This is a stratified sample because, help me spell stratified, because they are dividing them into strata, dividing them by teams, and then picking 2 from each team. That way, once they pick 2 from that team, no one else from that team can be selected. So the answer is definitely no. And now it's this no, it's B. I'm not going to circle that whole thing because we want all possible groups of 32 wrestlers to be chosen, even if 20 of them are all from the same team. You're not selecting all possible examples there. Okay, number 20. Of the following, which is not a critical part of designing a good experiment. Okay, and so look here at random assignment, random selection. Okay, we know these 2 are good. We want control, we want replication, but we want random selection of the subjects. So which is not, this person selected A. This is it. We don't want to randomly select subjects. We want to randomly assign subjects. Okay, so what aspect of an experimental design is going on here? Does donating blood lower cholesterol levels? So they had 50 volunteers have a cholesterol test, donate blood, then do another cholesterol test. Well, we're doing a comparison there, but what are we controlling? Nothing. There's no blinding going on. We don't know. There's no placebo. There's not a control group, even if we're comparing them to each other. Okay, we don't know about randomization because they were volunteers. So it is none of these. That is none of these. Okay, next question. If we wish to compare the average PSAT scores in girls taking AP stats at this high school, the best way to gather this data, that is a census. That is a census. There's not that many. Even if there's 40, even if there's 100, it'd be easier to get those numbers than trying to do a sample. Okay, what is true about sampling? An attempt to take a census will always result in less biased sampling. We don't know that. That's not always true. Sometimes it generates more bias because the group is so large and they all have the same view. Sampling error is usually reduced when the sample size is larger. That is true. Sampling error is the result of random variation and is always present. That is also true. So it's 2 and 3. So that answer is E. Sorry. There we go. All right, number 24. Does regular exercise decrease the risk of cancer? Another comparison here. 200 women over 50 exercise regularly, paired with a woman who has similar medical history but does not exercise. Then they follow the subjects for 10 years to see which group develops more cancer. What is missing there? Control. So this isn't any kind of experiment. It's not a randomized, it's not a matched pairs experiment. There's no control going on here. So it's some type of study. Retro means past. Prospective means what's going on right now. Definitely not a survey. So the answer is D. In an experiment, the primary purpose of blocking is to reduce variation. Remember, we want to block to get things as close to the same as possible. To get things as close to the same as possible. Oh, looks like the rain's slacked up. It's time to go home. So here we go. Let's finish these up. Fair coin has come up heads 10 times in a row. The probability, again, is 50%. We know that one. Okay, so 5 juniors, 4 seniors applied for 2 open council positions. What's the probability they're both juniors or, which means to add, or both seniors? So, because they're picking them randomly. So the probability of both juniors is going to be 5/9 times 4/8 because there are 5 juniors of 9. We pick 1 junior. There's 4 juniors left. There's 8 people. Or, here's our plus, 4 seniors is 4 out of 9. Take 1 away. That gives me 3 out of 8. And if we multiply this, add them together, and we're going to get D. Which of these are a binomial model? Okay, binomial means a fixed number of trials. Number of aces in a 5-card poker hand. No, I know there's only 5 cards, but the probability doesn't stay the same. The number of sodas students drink per day. Well, there's no fixed number. The number of people we survey until we find 2 people who have taken statistics. Again, no fixed number. The number of people in a class of 25 who have taken statistics, and there it is. We have 25 trials. We're trying to determine how many of those have. The last one here is binomial, which ends up being this one down here. It's the same answers, just switched around. Binomial, geometric, until we find someone, that means the first who has taken statistics. Okay, on this problem, we have 12% of all teenage drivers have ticketed for speeding, 9% through a red light. I'll do a Venn diagram here real quick. So we know 4% has the same here. All right. We know then if this is speeding and this is ran a red light, well, 12% have this. Well, 4% is here. So I take 12 minus 4. That leaves 8% here. Take 9 minus 4. Oh, you can't see my thing. I'm sorry. There it is. Starting over. 12%. 8 plus 4 is 12. This is 9 because 4 plus, this is 5 because 4 plus 5 is 9. So what's the probability a teenage driver has used a ticket for speeding but not for running a red light? That's 8%. Okay, that is 8%. 2 events that are most likely to be independent. Okay, 3 inches of snow have fallen, being on time for school. No, that wouldn't be it. Registering to vote and being left-handed. Those have no relationship. There's no association there. So yes, those events are probably. Okay, these others are also no. There's some association there. Okay, Pepsi is running a sales promotion in which 12% of all bottles have a free logo under the cap. So here we go. This is little p equals 0.12, and I'm going to go ahead and put Q equals 0.88 just to show we have those numbers. Grab my calculator over here. Okay, so what's the probability you'll find 2 free ones in a 6-pack? So this is binomial. It's binomial because we have fixed number of trials. So here we go. So second distribution, go up to binomial PDF. We're going to PDF because we have an exact number of 2. We have n equals 6, x equals 2, p equals 0.2. Oh, look at that. It's already in the calculator. So I press enter, 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 Enter. There it is. So that tells me binomial CDF of 6.12 2 equals 0.1295. Well, the closest number to 0.1295 is 13%. That's a binomial PDF. You said CDF. You said PDF and wrote CDF 3 times. What a knucklehead. Sorry, binomial PDF 6.12 because we had exactly 2 cokes. All right, 33. Which of these random variables has a geometric model? First success. First success. We find someone with green eyes. That is C. Okay. Find 3 bad muffins. That's 3 successes. 10 cards in a shuffled deck. Never, ever, ever do we use cards. Don't use cards. Here, the number of Democrats among 20 adults chosen. That's not geometric. That's binomial. And sure enough, we turn the page, and that's our very next thing. The number of Democrats among a group of 20 randomly chosen adults. So that one's binomial. Okay, so we have a friend tossing coin 200 times. So she's already tossed it 20 times, and we got 15 heads. So this is total. This is heads. This is tails. That means if she's doing it 200 times, then she has 180 left. Well, how many do you expect? So expected value would be NP. The number times the probability. What's the probability of getting heads? Is 0.5. So that would be 90. So then 90 heads here, 15 heads here, 15 plus 90 is E105. Okay, so the 3 free response questions on this, you're going to have a normal model, which is going to have to be this. You're going to have to label the mean, whatever it might be, and you're going to have to go 3 standard deviations both directions, and you're going to have to tell me all these numbers in here. Okay, I need to see all this.